Hello everyone, we are going to introduce the SkyWalking 8.0 dashboard. The dashboard is new from the new page. Currently, we have the global service instance and endpoint panel and the database for the agent case. In the current global case, we have the service load and the slow service, unhealth service based on the APTX and the slow endpoints from the global review. Then you can have the which service have the most traffic and which service or endpoints are the slowest. Even from the AppDex perspective, based on your definition, which service is unhealth mostly. So you should focus on the optimized service. At the end, there is a global latency percentage layout and global latency heat map. So most user maybe want one of them. If you get used to use them, that show you how your latency layouts, not just the average response time. Also from the service perspective, you have the service load. Then such as in traditional service, you have the average response time, successful rate, and the load and AppDex as usual. You could also have one value or have a line graph showing every minute status. At below, there is the instance status from the instance traffic, instance latency, and the instance successful rate. That will list you all of the service instance states. Then you can know all of the issue the service have is caused by all service instance, which means most basically a common issue or just one instance have that issues. If there are focus on one instance, that's most likely you are facing some kind of network or operation system or some firewall issue, specifically focus on that instance environment. Also, you can dive in at the instance perspective. There is instance load, instance successful rate, and instance latency. Also, if you are using the Java agent or .NET agent, you will have the JVM metrics and the CLR. From the endpoint, there are two parts of view. At the front, you will have the global review of all endpoints in current services. They will give you the brief about the traffic, the latency, and the successful rate. Also, you can see all of the metrics for this particular endpoints. You have the traffic, average response time, percentile, or successful rate. Also at the database dashboard, if you are using some language agent could detect your database access, you will have this. So these metrics includes the network issue. When these clients, such as in Java agent, when you're using the JDBC access database, when you set up the wrong database endpoint or your network is not reachable, then this also shows you the things goes wrong. Okay. Also, we will based on your slow circle access thresholds for different database, then you can have the slow statement. These slow statements are giving you chance to, from the application perspective, how to optimize this, and you also could use the tools from the database to change the statement and improve the performance. Also, another big thing is the topology. Every distributed system wants the topology. So when you have that, first thing you will see is about the global things, all of the services. But at the time when you have thousands services, all of these will be full of the nodes. So that seems not such practical. Also, in that case, we create and giving you the chance to create the group. So you can see we have two groups defined by me previously, and there is a load balancer zone and a busy zone. And these things are stored and defined at your client browser side. So everyone can have different one. And you have the name, and you can click and select the service you want. Then you have your group. Then you can switch from the group topology. Okay. Also, in every node of the topology, once this is a real node, the real node means you have agent or detected through the service mesh. Then you can click it and get the metrics of that service. Also, you can dive in at the instance level, or you can see the endpoints, how it looks like. Okay, that's the thing you are going to use for many cases. Such as this project C has a heavy traffic, they will see a lot of GC happens, and the latency is not stable. That's the thing. That's how you see what's going on. And you can switch the instance from these pages too. Okay, then we move to the trace. From the trace, that's a very traditional, and you should be able to see many trace view in different tracing system. Then in here, you have a different chance to switch the layout. There is a list, and there's a tree focus on the dive in, or you can use this button to show you the slowest and or which one have the most children, because that is two cases you want to identify your issue. If this slow, then this span, what's happened inside it is should be taken care. If you have a lot of children and these nodes are very slow, then you have too many cores, mostly too many RPC core and database access, cache access, something like that. Okay. Also, you have the table view. That's very traditional one to show you on the table. Also, this is a new fusion, and as far as I know, this SkyWalking is the only one provide these fusions in the open source world. And you can create tasks to focus on one service and giving you a very specific endpoint name, mostly UI, then you can start the profile. This is the result I already started previously, and you can have the result. This is the traditional part of the span. Part of the trace, we call that the segment. That means the span happens in one service, not distributed. Because all of the profile fusion should be used, you already have the tracing, you already have the topology and the metrics to identify which service has the biggest latency issue. Then you should use this to identify it. How these things works, basically you can understand this based on the thread dump and currently implemented in Java agent only. Also, we could talk more about how to make these things work in other languages, but right now this is not the agenda. If you want to understand more, there is an article written by me and Adrian of the Zikin and Liu Han from the other company. We wrote this article about how you identify all of these things, how to identify the performance issue based on the thread dump. And we integrate all of these to the SkyWalking. Then you have the trace-based agent, which also could do the profile. So the performance cost is very limited. You can do any profile like in the production environment and didn't worry to crash your whole system. Okay. And from this point, you can analyze the slowest span. Then from the analyzer result, you can see that's based on the network. So if there is a slow method here, you can also see this method. But in our case, the network is the issue. So you can see the java.net socket is the issue. Then we should not worry about code. We are worried more about the network configuration, the network latency, or there's some issue happens in the upstream. So we can move on. Okay. Also at the alarm page, you can review all of the alarms triggers in current status. that configuration could be configured as a static configuration from the YAML. Also, you can use the dynamic configuration service through gRPC to configure all this alarm rule. Right now, all of the alarm rule will be shipped out through the gRPC or HTTP protocol. You can use that to integrate with other platforms such as Slack, mail list, or your mail system, your alarm platform, any place you like. So I think that's the better way you can see and receive and deal with all this alarm information. Okay, this is the basic brief about the current dashboard. I hope all of you will love our new dashboard. And if you have any suggestion, any issue, we welcome you to join our Slack, our mail list, and our GitHub page. Thank you.